Let's start with another example. Same questions, different graph. Okay? So given the following graph is a function, so we know this is a function phi f at 0 or f of 0 and phi f at 2 or f of 2 and so on for part B, C, and D. It's a different question, very similar to the previous example. Let's start with this one. Part A, we need to phi f of 0. Okay? So what is y when x equals 0? So when x equals 0 is where both the x-axis and y-axis intersect, right? So 0, when x equals 0, y equal to, so that's up here, right? So you know this is 1, 2, 3, so this is going to be 4, because it's only 1 unit away. So the answer is 4. Okay, when x equals 0, y equal to 4. So unit notation f of 0 mean y at 0. So we mean when x equal to 0, y equal to 4. So another one we have is f of 2. So what is y if x equal to 2? So x equal to 2, look at the x-axis, pause it on the right, so right here. When x equal to 2, what is y? So look at the graph right here. It meets at the x-axis, right? So it's right here. At this point, the y is equal to 0. So that means at x equal to 2, y equal to 0. Okay? So for part B, determine the domain. Alright. Unlike the previous example, there's only 5 points. It's the finite case. This case, when you see the graph right here, is extend infinitely. So it's actually continue on. So the domain, again, what is the definition of domain? In the first coordinates, right? That means you look at the x-axis. You look across the x-axis. You see how this graph function expand. So if you continue on, you see that this will approach to the right infinitely. And same thing, for this path right here, it would extend to the right infinitely. You see that it is expanding out. So it means the domain is for all real numbers, so any x values. So we would say domain is, let's see, what did I say? I'll make sure you use the same notation. So I say domain is all real numbers. Okay, now in a quiz or midterm or final exams, read the question carefully. I may ask you to write the answer, the domain, in interval notations or in set notation. So let's practice. It's like review too. So let's write this domain in set notation, okay? Is, so what is the variable? Is x, right? So x such that x is any real numbers okay, so this is set notation. I may also ask you to write this in interval notation. And remember, interval notation, we use bracket parenthesis or any combination of them. Domain in interval notation is, now look at the x-axis, right? This graph expands further to the right and further to the left and further to the right, right? So it approached negative infinity to the left and it's approached positive infinity to the right. So in interval notation, it's negative infinity to positive infinity. Now remember, for negative infinity, we don't know how small it is, so we use the parenthesis. left parenthesis. For positive infinity, we don't know how big it is. We use right parenthesis. Okay. So part C, determine all x values such that f of x equal to 0. So f of x equal to 0. Phi x. So this f of x is equivalent to y, right? So we know y equals 0. What is x? That's the question. Now look at where is y equals 0. Y equal to 0 is here, right? It's actually on the x-axis. Y equals 0 is right here, at this level. So what point is that on the graph correspond to y equals 0? What x is that, or are that, if it's more than 1, that correspond to y equals 0? So look at the graph. How many points do you see? This is the point where y equals 0, right? So there's one point here. Look at that. There's another point, which is right here. So at this point, the y equal to 0, you don't know what x is. Same thing. At this point, you know y equals 0. So what is x? From the graph, we saw that x equal to 2, right? So I put 2 here. On this side, when y equals 0, x equals to negative 2, right? From the graph. So I put negative 2. So what x are that? Negative 2 and 2. So you say x equal to negative 2 and x equal to 2. Okay? Does that mean at negative 2, when x goes negative 2, guarantee y equal to 0. And same thing for this case. When x goes to positive 2, y equal to 0. Okay? For part D, determine the range. So this is not the finite case where we can locate every point. What x is, what y is. So now, for the case that the graph extend infinitely, you look at, for the range, you look at the vertical y on the y-axis, minimum y and maximum y, okay, on this graph. What is the maximum for y? You see this graph right here? The maximum it can go is what? Y equal to 4, okay? For the range, you look at the y, the vertical dimension. For domain, you look at the x dimension, okay? So for range, the max you can see is 4, right? So maximum it can get is 4, okay? And what is the minimum it can get to? Look at the graph. It's going and expand and it's going down and down to negative infinity, right? Because decrease going approach the bottom below the x-axis. So that means keep decreasing and decreasing and decreasing. So we don't know how small it is. Negative infinity is a symbol that represents that. So if I ask you to write this in interval notation, okay? So let me copy this. You know this is the smallest side, the biggest side. So how about this? Let's start with the set notation first. Domain in set notation is x symbol x, right? X such that x is between maximum it can reach, right? Because this point touch the tick mark at y equal 4, right? So that means we're including it. So you put 4 right here. So use the less than or equal to. How about negative infinity? Remember infinity, we don't know we don't know what infinity, how small it is. We use the symbol less than. Sorry, this is y because the range, not the x. Apologize. We talk about the range now. Range. Okay? We already talked about domain. Domain earlier. This is the range. So range in set notation is y such that y is bound between negative infinity and 4. Okay, you see it makes sense, right? The maximum is 4. That's why y is less than or equal to and is bigger than negative infinity. Now we can write this in interval notation. Interval notation. So we know the right endpoint we include, right? So we bracket 4. And the left endpoint is negative infinity, right? So we don't know how small it is. We use parentheses. So this is how you would solve this example. I give you more answer. I mean, like different type of answers. Just one answer, but written in 2 different ways. So to read the question, if I ask you to solve and write the answer in set notation, this is how you write it. If I ask you to write the answer in interval notation, this is how you write it.